Last week, we finally released the mintyPi Lite. I laid out all the features and compared it to the previous version of the mintyPi. So if you missed that video, be sure and check it out. But over the last week, people have started getting their parts in the mail. So today, as promised, I'm gonna show you how to put it together. Okay, so before we get started, a couple of things real quick. First of all, I'm doing a giveaway for a fully built mintyPi Lite. So if you want to enter to win that, check out the link in the description. There'll be a blog post with an entry widget on it. It's totally free to enter and the winner will be picked at random, so yeah, check it out. Also on that blog post is a list of all of the parts and tools and supplies like wire and things like that I'm using. So if you're putting one of these together, then definitely check that out as well. Helder still has some of his parts in stock on his site. I don't know how long those will last, but he does plan on doing another batch of those after this one runs out. So if you missed this batch, then sign up for his mailing list, follow him on Instagram and things like that to make sure that you don't miss it. I've also still got the 3D printed parts available on my site as well, but just make sure that you can actually get the parts from Helder to put it together too. If you've got your own 3D printer and you want to print out your own parts, I've got the STL files for doing that up on Patreon for supporters to download, and I'll have those up on Thingiverse for everybody else later this week as well. I also added a couple of models for things like the protective sleeve and the display stand, and an updated drill guide. So if you downloaded them previously, then you might want to go back and re-download them so you get the latest files. So with all that out of the way, let's get started. So I'll start with the part that seems to give people the most trouble, which is attaching the Raspberry Pi to the button PCB. Now, one thing you're going to want to make sure that you have for this part is some no clean flux, and make sure that you get the no clean kind. Helder got me using this stuff and it's just been fantastic. The stuff that I've been using previously and recommending is this, and it works just fine, but it leaves a lot of residue behind, which can sometimes, depending on the brand, actually be conductive, which can cause interference on some of those pins for things like the screen, for example. First, we're gonna put the boards in the 3D printed part to line them up, so you're gonna need your screws for that. We're gonna use the 3mm screws in the button PCB, and then apply a layer of that no clean flux onto all of these pads here. Now, for putting the Raspberry Pi in there, make sure that you orient it like this. There's always somebody that winds up attaching the Raspberry Pi like this. That's not going to work at all, and you're going to create a mess for yourself, so make sure that you attach it just like this. And then we'll use the 4mm screws here to attach the Raspberry Pi. Now you see this line here just above the Raspberry Pi? That's actually so that you can line it up perfectly with those pads underneath. So don't tighten your screws all the way just yet, get it lined up perfectly, and then go ahead and finish tightening it down. Now for this part, I like to take a couple of small clips and clamp down the Raspberry Pi just to press it against the button PCB, make sure there's not a gap there. And then this is the kind of soldering tip that I use. I get asked about that a lot. Not super narrow, but definitely not very thick either. So the easiest way to do this part is to take the solder and put it down in the Raspberry Pi pinhole. Then take your soldering iron and put it up to the side of it and turn that tiny bit of solder that's down in the hole molten so that it hopefully attaches to both the pad below and the pinhole on the Raspberry Pi. Stick the tip of the soldering iron in there for a few seconds, not too long or you'll melt the 3D printed part, and then pull it out quickly. I like to do a couple on both ends and then a couple in the middle, just to get the two boards initially attached to each other, and then if you want, you can unscrew it from the 3D printed part so that you don't have to worry about melting it. But if you're careful and you only use your tip in there for a few seconds, then you shouldn't have to worry about it. And then afterwards, I like to take a desoldering braid and clean up any excess, get it nice and flat on the surface. Next, you're going to want to take your multimeter, which preferably will have a beeping continuity mode, and test continuity between the test pads here just above the Raspberry Pi and their corresponding GPIO pinhole. This diagram will show you where each test pad should connect to, so you can make sure that you get a beep between each of those points. If you run into one that you don't have a good connection on, then what you can do is take a bit of wire, heat up the pinhole in question, stick the wire down in there, and wiggle it around a little bit. 9 times out of 10, at least for me, that'll let the solder flow down onto the pad below the pinhole and make that connection. Next, I'm going to attach the function button. That's going to go right here, and this is what the button looks like. It should come in your kit. Put a tiny bit of solder on one of the pads, line up the button, heat it up again to attach it, and then you can make sure that it's lined up properly. And then go ahead and add solder to the other legs. Next, we're going to attach the speaker to the button PCB, and for this I like to use 30 gauge silicone coated wire. It's just nice and flexible, it won't break on you It also won't melt when it gets hot from the soldering iron. Really nice stuff to work with. Attach a small piece, like ½ an inch, to both of the outer pads on the speaker and connect it to the PCB. Polarity does not matter on this, so it doesn't matter which one goes to which side. Next up, the power switch. This is going to sit on the power board just like this, and you can just hold it in place, attach one of the legs, make sure that it's lined up, and then attach the other two. Then go ahead and press it down into the 3D printed base so that we can attach the L&R button board. If you look on the other side of it, you can see these little pads here at the bottom left. There are 3 corresponding pads on the power board. So slide it in place, line everything up, and then put a nice blob of solder onto one of the pads, and then drag it upwards onto the L&R board. And then after you do the other two, it should have a nice strong connection between the boards. So now for the battery. You have a couple of choices here. You can either use the official custom battery, or you can use a pouch battery like this one here. If you look at these things, there's a series of numbers right here. That's actually a code that represents the size of the battery. So the first 2 digits, that is 5.0 millimeters thick. The second 2 digits, that means is 35 millimeters wide, so no decimal there. And the last 2 digits, it's 62 millimeters long. I carved out some space in the base here. You've got 38 millimeters this way and 70 millimeters this way. And then the official battery is right at 5 millimeters thick, although there is a little bit of wiggle room there. So if you're using that kind of battery, then you'll be attaching it to the power board here and here. Obviously on the bottom is positive, and then up here at the top is ground. Here's what it looks like attached to a prototype board. Again, positive on the bottom and ground there at the top. Now, if you're using the official battery, then you're going to need to attach this connector to it that comes in your kit. It rests right here, and you can just set it in place, add a little bit of solder to each of the pins, and that's it. Just make sure that it's nice and flat against it. If you flip over the power board, you can see some holes in the board that legs on this connector slot into. So just to reinforce it and make sure that it stays in place, add a little bit of solder into each of those holes to make connections with those legs. Again, just to reinforce it and make sure that it doesn't break off. Next, we're going to attach the power board to the button PCB. Previously, there was a little bundle of wires that did this for us on version 3, but now we need to run some wires. And if you hold the 2 boards like this, then the wires just run straight across. So ground there at the bottom, and then power, and then the L&R buttons. Again, I like to use silicone coated wire for this just because it's so easy to work with. But here, since it's carrying power, I'm using a little bit thicker, so I'm using 28 gauge. And there we go. Like I said, if you hold the 2 boards like this, the wires just run straight across, and you're going to need, I'd say, about 1.5 inches to 2 inches. If you don't give yourself enough slack, then it's going to be really hard to get everything into the tin, because the wires kind of fold over and sit like this when it's in the tin. And after that, you can put your buttons in there and screw everything down again. And that's it for the electronics. Alright, so now we'll get our SD card ready. First, go to the blog post that's linked to in the description, and there will be a link to a pre-made software image that you can download and flash to an SD card. Then go download an app called Etcher from a company called Balena. Now the software image will have a file extension of .gz. You don't need to try and unzip it or rename it or anything, just use it as is. Drag it onto Etcher, then select your SD card. It might warn you if it's above a certain size, and let it do its thing. Remove it and reinsert it into your computer, and you should see a new drive called boot. Go into there, and there will be a file called WPA supplicant. If you used a Raspberry Pi 0W, then you can go into this file and edit the text between the quote marks on this line to put your network name, and then same thing on the line below for the network password. Save it and close it, and now when you put this in your Raspberry Pi and turn it on, it should automatically connect to your network. And by the way, a huge thank you to Bloop for all of his work on the scripts that we're running for the battery monitoring and all the shortcuts and everything. In fact, he stayed online with me super late the other night, helping me troubleshoot a few issues with it. So again, huge thanks to him for that. If you're not following him on Instagram, then you should be. He's got some really cool projects coming up, including a new Game Boy Pocket board that I'm pretty excited about. So yeah, check it out and give him a follow. Once you've got your SD card set up, then you can connect your screen and make sure that everything works. Note the orientation of the ribbon cable here, with the screen and the button PCB facing down, and the blue tab should be facing up. And after it boots up, you can try out all the buttons. Make sure you also test the function button, start up a game, and make sure that the speaker works too. If something isn't working right, the first thing that you should check is your soldering. Go back to that diagram and make sure that you have good continuity between each test point and the corresponding pinhole on the Raspberry Pi. Now for the tin, and if you're doing this part by hand, then you're definitely going to want a drill guide to show you where to drill the holes for everything. It just snaps onto the bottom here. Make sure that the holes for the power switch and charging port and everything are on the left hand side. And for the L and R buttons, I've got something new this time around. The holes are much deeper and wider, so if you're really brave or you've got a drill press, you can use a 3/16 inch drill bit to very carefully and slowly drill the holes directly to the size that they need to be instead of having to step them up like in previous versions. Again though, you've got to go really slowly and carefully, but it does work and it can save you some time. But if you're not comfortable doing it that way, you can actually turn it around, and I've still got the tiny holes just like last time so that you can poke a pin through them and mark exactly where you need to drill for the L and R buttons. Then you can take as small of a drill bit as you've got and keep drilling the holes, stepping it up a size each time until you finally get to that 3/16 inch drill bit. Then for the charging port and the power switch, you can drill some pilot holes and then use a fine tip marker to mark roughly the size and shape of those holes, and then go at it with a set of files like this one. Here's a clip of me doing that on version 3. Same process, just go at it slowly and carefully and check it often to see how you're doing. I think that most people are going to want to take advantage of Helder's laser cut tins that he's offering. These things are super precise and they'll save you a ton of time, and he can even do customized blank ones as well. And now it's time to put everything in the tin. I'll start with the screen back. This is what the screen sits in and the bezel snaps into it. To attach that to the tin, I will be using VHB tape like I have in previous versions. Just use a few strips of it, something like this. That should hold it in place pretty securely. This stuff is really strong. Then set it into the base of the tin. Make sure that you have it oriented just like this, and then carefully close the lid so that it sticks to that tape. Open it back up and it should be perfectly aligned. Next, take your L and R buttons. I know they're really long right now. We'll trim them down here in just a second. Put those in, and then carefully put the base with the power board in it inside the tin. Now for attaching the base, I still like using hot glue. I know that I catch a lot of flack for doing that, but it's worked great for me. I've never had a problem. This is the kind of glue that I use. It's super strong. If you want something really permanent, you could probably use something like this, although I've never tried it. Obviously, it's just going to take a lot longer to set. I like to put a little bit in each corner, and honestly, I've never run into any issues with it coming loose. If you're using the custom battery, then go ahead and slide that in. Otherwise, you've probably already got your battery in there. Attach the hinge just like this. Angle everything in there. It can be kind of tough, but just be careful. Make sure that you don't snap off your SD card or anything like that. Then take your screen and attach the ribbon cable like so, and carefully place it into the lid. Make sure that the hinge is resting in that cutout on the top part, and carefully push the bezel into place. And that's it. One thing that you're going to want to make sure that you do is hold the hinge firmly and then gently work the lid back and forth a few times to kind of smooth out that 3D printed part. Once you do that, it should open and close pretty easily. Now we'll trim down these L and R buttons. That's what this little 3D printed ring is for. Just put that over each button and take some flush cutters and snip off the end, and it should make them just the right length. Alright guys, well that's about it. If you get stuck or you need help or whatever, check out the Discord server. I'll have a link to it in the description. You can also stop by the forums and ask for help there, although the Discord server is quite a bit more active these days. Also, don't forget to enter to win a fully built mintyPi Lite. Again, check out the link in the description for that. I'll leave the giveaway going for 10 days to give people a chance to enter, and keep an eye on my Instagram. That's where I'll be announcing the winner. Huge thanks to my Patreon supporters. As usual, you'll see their names at the end of this video. And yeah, I'll see you guys next time.